So now we are going to be using our properties of the segment addition postulate to solve example 3 and example 4. So get excited. So it says point B lies between A and C. AC is 21, AB is 2y, and BC is 3y minus 9. Find y, AB, and BC. So we currently do not have a picture, you guys, which means we need to draw a picture. Sorry. All right, so I'm going to get my ruler ready. We're going to be drawing a nifty picture. Okay, so point B lies in between A and C. Now, it does not say that A is the midpoint. So I don't have to put A in the midpoint. And I'm actually not, just so we don't get confused with that. Okay, so I have 3 points on this line. I have A, I have C, and then B is just somewhere on the line. I don't know. It might be over here. Okay, and again, this is not drawn to scale, so it's okay if my picture is slightly off. Like AB could be larger than BC. I don't know yet. Okay, it says that AC equals 21, so A to the C is 21. All right, AB is 2y, and BC is 3y minus 9. And it wants me to find all these nifty things. All right, so I'm going to set up the segment addition postulate, which states if I take a segment and break it down into its pieces, it will equal the entire line. So this means that segment AC, the length of AC should equal all of its parts, or all the segments within it added together. So this will equal the length of AB plus the length of BC. All right, I'm just going to substitute everything in where it goes and then start solving things. It's going to be exciting. All right, so my AC, down here, my AC, it says is 21. So I'm going to replace that bad boy with the 21. 21 equals my AB, which my AB is 2y. So that's 2y. And then plus my BC, which BC is 3y minus 9. All right, guys, and now let's just start solving for y, which will help me to find all this other nifty information. So I need to combine my like terms on this side, which the only like terms I see are the 2y and 3y, which give me a 5y. Okay, so this is going to end up being 21 equals 5y minus 9. All right, guys, let's start solving this thing for y. So I'm going to bring my negative 9 to the other side, which the way I do that is by adding my 9 on both sides. Negative 9 plus 9 cancels, bam, cancels, turns to 0. 21 plus 9 is 30. Okay, so now I'm left with 5y equals 30, or 30 equals 5y. All right, my 5 is secretly multiplying to the y, so the way we bring that bad boy to the other side is by dividing that thing on both sides, which 5 divided by 5 cancels and turns to 1. 30 divided by 5 gives me 6. So yay, y equals 6. Awesome sauce. Yeah, there we go. All right, so my y is solved for. Now I need to find AB, BC, and that's it. So AB and BC. So I'm going to find those items over here. All right, which I know that my AB equals 2y, and I know that my BC equals 3y minus 9. So now that I know that y is 6, I can substitute in 6 for my y's, and bam, I'll know AB and BC. So let's get started. All right, so my y's are both going to eventually become a 6. Okay, so AB equals 2 times my y, which is 6. So 2 times 6. And 2 times 6 is 12. So AB is going to be 12. All right, so this is 12. And technically, I can already figure this out because if the whole thing's 21 and this piece is 12, if I subtract these two, I will get this value, which 21 minus 12 is 9. So technically, I already know what BC is, but it doesn't hurt to check to make sure my y value is correct. Okay, so BC equals 3 times my y value, which is a 6, minus 9. All right, let's see what happens. So 3 times 6 is 18, and 18 minus 9, holy hot dog, it is 9. So my BC is 9, my AB is 12, and my y is 6. Holy hot dog, wasn't that an epic problem? I agree. It was totally and utterly epic. Nice job, you guys.